What is the Mann-Whitney U test? When do we perform this test and how to perform this hypothesis test? In this video, we will try to understand that. The Mann-Whitney U test is a non-parametric hypothesis test. This test is performed to compare the median of two independent groups. For example, let's say we want to test whether the median calcium levels in the rainwater of two different cities are the same. So, we collected the data for 10 days in two different cities and found out the calcium levels present in the collected rainwater. Here is the data corresponding to the test. Now, we want to know whether the difference in the medians of the calcium levels present in the rainwater in two different cities is statistically significant. To do so, we need to perform the Mann-Whitney U test. Please note that there are certain assumptions about the Mann-Whitney U test. They are: the observations should be independent of each other. There should be no relation between the two groups. The observations are not normally distributed. The dependent variable should be ordinal or continuous. We should be able to rank the values of the variable. The independent variable should consist of two independent categories or groups. So, let's look back at our example. Our null hypothesis is that there is no significant difference between the median amount of calcium present in the rainwater of the two cities, and the alternative hypothesis is that there is a significant difference between the median amount of calcium present in the rainwater of the two cities. Let's also assume that the level of significance alpha is 0.05. So, to perform this test, we will first rank the amount of calcium present in the rainwater of the two cities. We will rank the amount in ascending order. So, after ranking the data, the table should look like the following. Now, we can see that the calcium level associated with ranks 4 and 5 are the same. So, we will replace the ranks with the average of those ranks. So, we will replace ranks 4 and 5 with 4 plus 5 divided by 2, that is 4.5. Similarly, the calcium level associated with the ranks 16, 17, 18 and 19 are the same. So, we will replace the ranks with the average rank, that is 17.5. After replacing the tied ranks, the table should look like the following. Now, our sample size is less than or equal to 20. So, we will calculate U1 and U2 in the following way. U1 is equal to R1 minus N1 into N1 plus 1 divided by 2, and U2 is equal to R2 minus N2 into N2 plus 1 divided by 2. Here, R1 is the sum of ranks of group 1 and that is equal to 101.5 after calculation. R2 is the sum of ranks for group 2 and that is 108.5 after calculation. N1 is the number of observations in group 1, that is equal to 10, and N2 is the number of observations in group 2 and that is equal to 10. So, if we put the values, then U1 is equal to 46.5 and U2 is equal to 53.5 after calculation. The lower of U1 and U2 is taken for consulting the significance table. So, we will take U is equal to 46.5. Please note that U1 plus U2 is equal to N1 into N2. For us, N1 is 10 and N2 is also 10. So, we will look at the value in the table for the row with the value 10 and column with the value 10. From the Mann-Whitney significance table, we get the critical value for the two-tailed test to be 23. In our case, U is 46.5, which is more than the critical value of 23. So, we fail to reject the null hypothesis. Hence, we can conclude that the difference between the median calcium level present in the rainwater of the two different cities is not statistically significant. I hope this helps. Interested viewers who want to know more, please visit the website of the security body or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.